Welcome back to another episode of Thinking Critically. Today I'm joined by Jaclyn Ferraro, who is currently the Group Director of Petrography over at the CTL Group. She has experience in evaluating concrete structure materials and aggregate using polarized light microscopy, scanning electron microscopy with X-ray spectroscopy, and other petrographic methods. She performs petrographic and microscopic examinations on rocks, minerals, cement, and other construction materials to assess the quality and condition of concrete. Her expertise also includes, but is not limited to, structure and material issues pertaining to strength and setting issues, freeze-thaw and chemical-related deterioration, alkali-silica reaction and alkali-carbonate reaction, delayed Ettringite Formation, fire damage assessment, scaling, debonding, and delamination. She earned her bachelor's and master's degrees in geology from the University of Iowa, where her master's degree focused in structural and economic geology. Anyway, Jackie, thank you so much for agreeing to come on.
Thanks for having me.
Yeah, absolutely. It's fantastic to have a geologist on the show. You would now be number 2. However, the first geologist that I had on the show was more from a comedic standpoint, because that's what he's interested in right now.
Oh, okay.
Not so much geology, but today we'll dig a little bit into more of the geology. And anyway, I am very curious to kind of hear how it is that you became interested in science in the first place. So kind of where did it all start for you as far as your interest in science?
Yeah, so I think that my interest in science really started when I was a kid, but I didn't know it. I really was the kid that asked a lot of questions. I grew up in a house that had a forest preserve in the backyard, so I spent a lot of my time exploring back there and finding different plants, rocks, animals, and I would take what I found and just go to the library, find the nonfiction books that related to those things. I was never big on like the fiction books that we were assigned in school. I always wanted that reality. So yeah, I think that the nature aspect mixed with the science aspect is really where the geology came in for me, and I didn't realize it yet. But growing up in Chicago, you don't really hear about geology. It's more career paths of some type of business standpoint or medicine. So when I decided to go to college, medicine, that's science. So I took off with a bio pre-med major. And 3 years in, I decided it wasn't for me. I spoke with my advisor at the time, and she asked me probably the most life-changing question. And she asked, what did you do, or what did you like to do as a kid? And I told her exactly what I just told you. And she said, well, what about geology? And I said, what's geology? And so she registered me for a geology course, and I loved it. So I switched my major about 2 or 3 months in and just took a completely different track. In geology, I ended up taking structural geology, which it was just a subject that I really loved. I don't quite know why. I think that the deformation mechanisms that happened interest me, and the level at which they happen at. So the microscopic level, the regional level, and then also a tectonic level. Structural geology also incorporated the different subsets of geology. You didn't just look at the faults that were happening. You looked at the faults that were happening within that rock type, the rheology of that rock type. So the incorporation of not just structural geology was something that I liked a lot.
So that's interesting that you said that you went down the pre-med route and you did it for 3 years. That's a long time to devote towards one particular path and then all of a sudden decide that, hey, this isn't for me. But I mean, good for you to finally, admit to yourself that this isn't working out. Because imagine if you had ended up graduating with the degree, I suppose, in biology, was it? Yeah.
Yes.
In biology, and then you're like, man, I don't even want to do this.
Yeah.
Like I don't want to. Go ahead.
No, it was definitely a bit of a panic attack moment, and I think my parents had some panic attacks as well from it. But you know, I've never looked back. It's just been the best decision I've made for myself.
I think a lot of people actually go through something similar. I mean, I know myself, I mean, I have a bunch of family members, a bunch of friends that do the same thing where, you know, you go into college with one thing, you think that that's what you want to do, and then you change it to something completely else. And for me, I went in as a mechanical engineer because I didn't really know what I wanted to do. And I knew that I liked technical things, science, etc. And that with engineering it would be like a good career path. And I had an engineer in the family who was very influential in getting me interested in science, engineering, technology, things of that nature. So I went into college as a mechanical engineer. And then after the first year, I was like, I don't really like this. This isn't kind of what I am passionate about. So then at that point, that's when I decided that I wanted to switch to geology. Then of course I changed when I was actually in graduate school, but I did end up finishing my degree in geology, which I have no regrets about, even though I don't work in geology now. I thought that the program that I went through was absolutely fascinating. I'm a huge fan of geology in general because I just think it's really, really interesting learning about planetary processes. I mean, also seeing the integration of the various other sciences into geology, I thought was fascinating. So you have like mineralogy, which is essentially a confluence of geology with chemistry, or the structural geology. I was really drawn to structural geology as well. I have something where certain visuals really, really appeal to me. So one of the reasons like I'm really drawn to certain types of mathematics is not so much because of the types of problems that are being solved, but the types of math that you get to use from a visual standpoint. So with structural geology, I thought it was really cool because of all of the different diagrams and the way that you mapped all the different types of maps that were being made,
Yes.
as well as the, you were talking about the, like faulting, things of that nature. So the various types of faults, but just like going through the textbook, like a structural geology textbook. And there's so many really interesting graphs. And then also above and beyond that, I've always been super passionate about physics. So structural geology is kind of I think of like an intersection between geology and physics.
Yes.
I know that there's an actual section of geology called geophysics, which I studied as well, but I always thought that that structural geology was more of like more appealing from a from an intersection of geology and physics standpoint, I suppose, where you could really see how it's applied to planetary processes. Where when I took geophysics courses, it was more like remote sensing techniques and things of that nature. It was basically how could I view what was going on below the Earth's surface, versus with structural geology, it's actually describing what's happening, not what can I view below the Earth's surface to see what's going on, but trying to describe what's actually happening. So, and yeah, I guess what I'm saying is I can understand why you were drawn to structural geology. It's very interesting.
It is very interesting. Yeah, it's sort of along the lines of what you're saying. I really liked applying what I learned in the classroom for structural geology to the field, so that the geoscience 6-week course that you have to take, and you do the mapping of the mountains. Actually, that 6-week course was the first time I had ever been in the mountains. But I loved it so much, and I really excelled at it. And yeah, just mapping at the surface and then being able to project what you think is happening at depth too.
So I'm guessing what you did was you went out into the field with a compass, and you did a bunch of like strike and dip measurements or something of that nature, and then you just built maps of the region?
Yes.
Yeah, okay. So for those who are uninitiated, what exactly is a strike and dip real quick?
Yeah,
I don't.
It's just measurements in the horizontal and vertical field of the bedding of a rock or an outcrop, I should say.
Okay. Yeah, because it's been so long since I've actually done it. And yeah, that's a pivotal tool that a lot of geologists use in the field. They go and do the strike and dip measurements when they're trying to map a certain region, because it can help you figure out what the layers are doing in various parts within a certain region. And you're talking about the field camp. I did a field camp as well when I was doing my undergraduate degree, and unfortunately, I did a more we had two paths. We had a hard geology path, and then I had what was known as an environmental geology path. I ended up going down the environmental geology path because it allowed me to take more courses out of the department. So I was also interested in improving my math education. So I was taking a lot of math courses beyond geology. But because of that, I ended up taking the environmental geology field camp or field course, which is, I don't know, it was like 6 weeks or 8 weeks or something like that over a summer semester. And unfortunately, we didn't get to go out west and see anything cool. Like it was kind of local, and we did a bunch of soil stuff, which I'm not super interested in. As you know, around here, it's not very geologically interesting. So we examined a lot of like glacial till. And so till is essentially a word for sediment for those who are unfamiliar. But yeah, we just were looking at a bunch of like sediments and things of that nature, because there's plenty of it, which is great for farming, as you know. Yeah, we have great farmlands over here, but it's not terribly interesting from a geologic standpoint. So I was always slightly jealous of the hard rock people that went out west, because they actually went to like Colorado or Utah or somewhere that is far more geologically interesting than around here. But I'm curious, where did you do your field camp?
We were in Montana.
In Montana, okay.
Montana, yes. So
right.
We stayed at the university out there, and actually there were a lot of other schools that were there at the same time. So you weren't just creating that network with the people at your school, but you were also networking with people at other schools. So I actually became friends with a lot of people from Idaho and Utah, and so I still talk to those people too, which those are great networks to have for future and career. You're in your bachelor's degree and you're going to look for a job after, or you're going to go to your master's, but either way you're going to need that career path after, and those people can help you on that track. They might have a job where there's a job opening and you can apply to that. So, and that's kind of where I got the job at CTL Group. So
really, through one of your networks at field camp?
Not at field camp, but in my graduate degree.
I see. Okay. Yeah. So anyway, while we're on the topic of your graduate degree, I'm curious as to what you did your master's research on.
So the title of my thesis is the relationships between deformation and mesothermal veins in the Sunshine Mine area in the Coeur d'Alene district of Idaho. So before I go further, I kind of want to explain what mesothermal veins are.
Sure. Because I don't know.
Yeah.
The people listening probably don't know either.
Yeah. So you probably know what a vein is, though.
I do. I don't know what mesothermal. I could guess, but I'd rather just have you explain. So go for it.
So a mesothermal vein is a type of deposit that happens within a planar fractured surface, and it's from some type of hydrothermal activity, and usually that hydrothermal activity is at a moderate temperature, moderate pressure, and that's around like 200 to 300 degrees Celsius. So if people are wondering in Fahrenheit, it's upper 300s to upper 500s. So the relationship between the deformation and the mesothermal veins, the region that I worked in, the Coeur d'Alene district, they are known for producing lead, zinc, and silver since the 1880s. But the district did not have a predictive model for exploration based on the structural controls for the ore deposits. So my work pretty much focused on the geometric and spatial relationships between mineralization and the major structures that host the mineralization. I was able to establish a relative timing of the mineralization with respect to the structures that host the mineralization. So the fault kinematics in the area, there was like a regional fault system, and it was superimposed on regional deformation fabrics. And what I mean by deformation fabrics is like the planar fractured surfaces that I was describing where the veins deposit. So the intersection between that fault system and the deformation fabrics is pretty much where I projected where the silver ore deposition would be. So that was an exploration model that I developed for that mine. And that was my thesis. That was what my thesis was on.
That's really interesting. So did that end up actually being used by any sort of mining companies or anything of that nature?
I think it was specifically for the mines in that Coeur d'Alene district region. I did have people that worked at the mines contact me because it's not just Sunshine Mine. There's several other mines in that area. And it wasn't, I never had someone from Sunshine Mine contact me, but it was from the neighboring mines, and spoke with them on LinkedIn about my findings. And yeah, so actually, when you have your thesis online, you can see where it's pulled up and like what countries people are reading from. And it's been pretty global that I've seen my thesis being pulled up, which is pretty exciting.
No, yeah, that's awesome. So people from all around the world are reading your thesis because they found it that important. I know that it only pertains to one certain area, but probably a lot of the methodologies that were developed within the thesis, within your work, could be then moved laterally over into mines anywhere in the world. So
yeah, likely, definitely.
Yeah, perhaps that's why. That's really cool. I cannot say the same about my master's thesis. My master's thesis was it wasn't in geology, it was in physics, and it was so esoteric that I don't even know I don't see any sort of applicability or application in the real world anytime soon. It was dealing with some sort of bizarre material known as solid helium, which only occurs under very intense pressures and essentially almost 0 Kelvin or absolute zero. And like I said, not nearly as applicable as your research. So
I'm sure you learned a lot.
Yeah, no, I did. It was definitely an interesting project. It wasn't my first choice, but that's where I ended up. And I thought it was interesting, but again, from an applicability standpoint, I don't see it translating over to the real world anytime soon. But anyway, I digress. So, all right, so you've got your master's degree. You graduate, you met some contacts, and you found out about your current employer, CTL Group. So I'm just curious as to why you decided to go with them. So you were introduced via a mutual friend or something of that nature. And I'm just curious why it is that, you were like, okay, this is kind of where, this is where I'd like to work. So I'm assuming you applied a bunch of different other places. I'm sure you probably had offers elsewhere, but why CTL Group? Yeah.
CTL Group really was the package deal for me. It was a place where I could continue my education. So concrete petrography is not taught in college. you do need a geology background in order to become a concrete petrographer, but additionally, you need 5 years under a qualified petrographer. So that qualified petrographer needs to have at least 5 years of experience. And yeah, so it's continued education over the next 5 years from when you start, as well as I just was really excited to work with and collaborate with these other experts in other fields. And these experts are really well known to the people here at CTL Group, are some of the most intelligent people I've met. And, you know, we have architects, structural engineers, mechanical engineers, materials engineers, as well as chemists. We have coding specialists, and of course, petrographers. So the cross-disciplinary learning, as well as the concrete petrography learning, was a big selling point for me. When I interviewed for this position at CTL Group, the people were very nice, and they interacted with each other in like this close, genuine way. And I know that when you go into work every day, you have to like the people that you're around. So that was just an additional draw for me too. So yeah, it was pretty much the whole package for me of why I chose CTL Group.
It sounds like it. I mean, you get to be surrounded by brilliant people, so of course you can improve your own skill set, continuing education, and then liking your coworkers. I'm glad that you brought that up, because I can't think of anything worse than being stuck in a toxic work environment, or an environment where you just don't feel like you fit in.
Exactly.
Or yeah, so yeah, that's fantastic, and that you found something, that you kind of found some place that you could call home, because as you know, as an adult, we spend a good chunk of our time at work.
Exactly.
We do it for 40 plus years. Anyway, what exactly is petrography? Because there are probably some people who are listening that don't know exactly what petrography is.
Yes, so petrography is the study of rocks under a petrographic microscope, essentially. But what concrete petrography is just the study of the construction materials, or the construction making materials, like parts of the materials. So if you have concrete, you have all the components of concrete that we study as well. We look at those under various types of microscopes. And typically it's in a very forensic way. So we look at these elements to solve a problem. And that's the gist of what we do, the summary, I guess.
The summary: rocks under a microscope.
Rocks and all the other construction materials.
And all the other construction materials. So where, so your current role is technically, so you're a group director, but also as far as from like a scientific standpoint, what exactly do you do? What is a day in the life of Jackie look like at CTL Group? So what science are you doing? Well, obviously it's petrography, but what exactly does that look like?
So yeah, I usually get a project in that our client tells us something's wrong with. Maybe, I guess something the listeners would be familiar with is when you see concrete that's chipping at the surface, you just see these chunks out of the surface. That's a pretty common one. We call that spalling or scaling. And so say I get a spalling or scaling project in, I do some type of initial observations on these cores, and then we cut the core in half and we polish one side of it. We look at things like the aggregate gradation, the distribution, the color of the concrete. Then with the other half, we end up taking a thin section. We take a little billet and grind it down so we can look at that under a cross-polarizing light microscope. The cross-polarizing light microscope is that typical microscope that everybody sees, you know, that if you picture a microscope in your head, that's what everyone's going to see. So we look at the concrete under that microscope, and we look at the cement grains, any other possibly secondary deposits that are happening, and we take all of that information and write a report for the client saying, you know, from this issue, this is what we're seeing is causing this issue. And yeah, we get all different types of projects, and that's pretty much what we do from a technical standpoint.
So it's primarily dealing with cement then?
No, we deal with concrete, cement, the supplementary cementitious materials that are used. We study fly ash, all these components that go into concrete that
okay.
And things like mortar, bricks, you know, those dimension stone, like decorative stone, any type of material that you build with, we look at.
Okay. All right. And so I am fairly ignorant to building materials. What is the difference between concrete and cement? Because I noticed that you address them as two different things. I did not know that. So I'm curious as to what they are.
And actually, yeah, I mean, I should have known that. A lot of people don't know the difference. So cement is actually the stuff you see in the bag, you know, just that gray powder. And then concrete is the mix of that gray powder with water, with aggregate, maybe some type of admixtures, possibly some other components. So concrete is the end result, and cement is just a component in concrete.
Okay, I see. And when you say aggregate, is that just like loose rocks? Is there a particular type of material that is generally composed of the aggregate that's used in concrete?
So yeah, it's just loose rocks. We refer to them as coarse aggregate and fine aggregate. The fine aggregate would be more of a sand size particles, and then the coarse aggregate would be something that maybe has largest dimension of, it depends on the structure, but imagine something around 3/4 inch size.
Okay.
And both of those components go into the concrete. The aggregate type varies. Usually people like to use the aggregate that's local in their state or wherever they may be. But we do test that aggregate individually as well. So each aggregate that goes in, we need to say whether it's compatible with, you know, cement. It can't have a reaction, or else you're going to see cracking, you're going to see these different issues that occur. So, yeah.
Yeah, that would make sense, because if you were, you know, if the aggregate that you're mixing with the cement is not agreeable, or there's some secondary type of reactions taking place, that would definitely weaken the overall concrete. And then whatever structure you're using to build that concrete with is then going to be weakened, and that could cause serious problems.
Exactly.
Yeah.
Exactly.
Okay, so you say that you get cores in. Now, is this from like the field, like concrete or whatever material that's already installed somewhere, and then you're trying to diagnose the problem? Or is it something from like, from a manufacturing standpoint, like, hey, we're a manufacturer of this particular type of building material, and we want your opinion on how we're doing it, essentially, I suppose. Maybe it's both. It's probably both.
That's exactly right. It is both. I would say in petrography, we usually see the aftermath. We see what went wrong. But, you know, there's some cases where we get things in before they're actually in placement. So Yeah, I would say maybe 75% already in placement, and then 25% prior to placement.
I would hope it would shift more towards before placement, because if you could catch the problems beforehand, that'd probably be the best way to go.
Yeah. So in petrography, we do see more of the aftermath, but the other groups in our company, they'll see the before math.
Okay.
Yeah, they'll be the ones testing the raw materials. They'll be the ones evaluating mixed designs. But yeah, that's not really my expertise.
So you see things afterwards, or they notice something after the material is already installed. Are you informed of what actually went wrong? Like do they tell you, like, hey, there was a collapse, here's some samples, can you tell us why it actually happened? Or maybe not a collapse, maybe not something that dramatic, but are you told why these things like what exactly happened?
Sometimes.
Sometimes. Okay.
Sometimes it's, and you kind of have to take it with a grain of salt too, because it's, if I tell you we're having this issue, this is what I think is happening, but I'm not an expert in it, and you're the expert. You're the one that has to figure it out. So you can listen to what they're saying, but ultimately it comes down to, what are you seeing in the samples? What am I evaluating? What's in front of me? And the person telling you what they think it is could be completely wrong. So you definitely have to gauge that.
Yeah, I could definitely see how the beforehand, if you knew what exactly went wrong with a sample, that could definitely bias your investigation. But it would be interesting to find out afterwards. Be like, okay, well, I don't know what happened, so here's a sample. I'm gonna do my investigation and then come up with the conclusion. This is what I think happened, and then actually find out what went wrong. Went wrong.
Yeah, and that does happen sometimes, especially in litigation cases where they don't want to bias you. So you're basically going into it blind, and you form your opinions, and then you find out later and you're like, yes, I was right, or oh, okay, I see where that could be. And yeah, it is a very interesting and diverse process.
So you mentioned litigation. So have you actually done investigations that were a part of lawsuits?
Yes.
Really?
Quite a few. Yes.
Quite a few. Okay. That's really interesting. I mean, I can imagine that the type of work that you're doing, you're talking about like structures perhaps failing. So yeah, there would probably be lawyers involved with something like that.
Yes.
Because yeah, I mean, structures failing, injury, death, unfortunately, probably sometimes.
Exactly.
Lots of money lost as well.
Yes, usually when they go to litigation, it is a big dollar amount. Yeah.
Okay. Anyway, so you've been working in industry for a while now, and I am curious as to the differences between your academic experience, like doing science in academia, versus how you do science in your lab at CTL Group. So like where do the two overlap? Where are they different? I'm just really curious to hear your thoughts on that.
Yeah, so I think that in academia, there's more of an open platform of kind of exploring your heart's desires, and you have multiple opportunities for financial support, getting grants from various places. And so you're kind of looking at more of a theoretical approach sometimes, where in industry, you're working within a budget and you have that one financial source, that's your one client for this issue that you're seeing. And sometimes that financial source, that client, either, you know, you present this information to them and they don't want you to go any further, or they don't have the money to pursue going further. So you have to just stop evaluating. And as scientists, you know, we're really curious and we want to find out more and more. And to just kind of stop right in the middle of it, if you want to figure out what went wrong, you need to do it on your own time, and not on the business, not on the company's time. You know, this is like after 5 o'clock, you want to figure it out, you figure it out on your own. But, you know, that's pretty much where the industry breaking information is formed. You know, these people that stay past 5 o'clock, that really develop more knowledge for the rest of the industry. And there's a lot of people at CTL Group that do that. There's a lot of hard workers here. But yeah, so I think in my experience, I've always sort of had an industry focus. You know, it pretty much started with my master's, being able to apply what I was seeing to a real world scenario, where sometimes I think in academia, we get bogged down of like what's on our computer screen, and we don't see outside of that. We don't apply it or make sure that it applies to the real world.
Yes, I definitely can relate to the lack of applicability sometimes within academic work. However, some of the work, while it may lack application in the real world in the immediate, it could take decades. It could take decades to manifest itself to where people finally realize that, hey, this work that was done, it has some actual market value. We can use it. It starts, you know, more work was built upon that work, and then it makes sense.
Yes.
I know for me, I definitely like to see some sort of application in the immediate future, not something that's like decades down the line. So I would consider myself more of an applied scientist. At least I like applied science more, even though I've done a lot of theoretical work myself. I do have, if I'm doing theoretical work, then I have like applied outlets. For example, something like this, where I'm able to, you know, take my scientific training and talk about science and try to go out and kind of positively impact the world to whatever degree that may be. But yeah, I definitely can understand the need to see what you're doing applied, and that in academia, sometimes you don't actually get to see that. And it's just kind of published, you know, a couple hundred people read it, and then it's buried. And that's unfortunate, but a lot of the research that is done is kind of like that. And hopefully some of it leads to other groundbreaking research that, you know, then can be applied to society. I mean, it doesn't mean that it's not important. So I guess for people who are like tuning in and listening to this, you know, the work that's done in academia, of course, is very important, but sometimes the application takes a very long time before you can actually see it. So the time and money that's invested into it takes a while. Yes. Whereas in industry, as you just explained, Jackie, you know, the budget is very much important. Having results that can be used almost immediately or in the very immediate future is paramount. I mean, it's about most important. I mean, it's just, these are just how businesses operate. So the academic university environment doesn't quite operate in the same sense that the business environment operates in. But hopefully the microscopes that you're using are about the same.
Yeah, we use some great microscopes here. So.
Okay, fantastic. So with the work that you're doing at CTL Group, you know, we're talking about building and construction materials. So clearly, the benefit to society is would you say safety, strength of like structural integrity? How would you describe the services that you offer, I guess, packaged up in, you know, in petrography, geological science, and apply it to the way it benefits society, I guess, is what I'm getting at.
Yeah, so I would say that we really determine the root cause of problems in the construction industry. And then determining those issues just helps us avoid those problems in the future. And yeah, like you said, the work that we do it keeps people safe by making sure that the materials and the components being used in construction are up to standard. I also think that, like I said previously, when we work on interesting or these groundbreaking projects, it just adds to the knowledge in the industry. So yeah, I think that's how we impact society.
Really interesting. And of course, I think as everyone can agree, having safe structures is super important. I mean,
yes.
Our cities are with, they've been described as concrete jungles, or just, concrete everywhere, huge sky rises, and even, outside of major metropolitan cities like Chicago, you have large structures. So concrete is basically used everywhere. It's a very popular building material. So making sure that it doesn't fail is, super important.
It is very important.
So what are the interesting projects that you're working on right now? And I realize that some of them may be proprietary, so obviously you can't talk about those. But I'm just curious, for the projects that you can talk about, what exactly are you working on?
Yes, so right now I have quite a variety. I am working on shotcrete, a shotcrete pool that's leaking. So trying to figure out why the pool is leaking. It has different plaster layers on the shotcrete as well. So we are not only evaluating the shotcrete, but looking at those layers to see if there's failure within the layers or between the layers. Another one I'm working on is just a simple air content analysis. So all concrete has, well, I should not say that. Some concrete has air in it, or air that was entrained into it. There's an air entraining admixture that's added to concrete to produce these little air bubbles. And it's used a lot in the Chicago area because air bubbles are needed for freeze-thaw resistance. What happens is in the winter you have snow fall, and then it heats up, and that snow melts, the water goes into the concrete, and if it doesn't have those little air void spaces to go to, it just goes into the rest of the concrete. And when it freezes again, that water freezes and it cracks the concrete. So right now I am just evaluating the percentage of air within a concrete sample. So that's another project. And yeah, I actually have a auditorium floor of a high school that has this epoxy flooring system on top of it, and they're getting these blisters between the concrete, the underlaying concrete, and the epoxy coating system. So I'm evaluating where these blisters are coming from, or what the cause of these blisters are. So those are a few of my projects right now.
So the epoxy one sounds really interesting to me, because that doesn't sound geologic related, but more of like a material science project. So because you're not dealing with like earth related materials, you're dealing with something that was that came out of like some sort of industrial process where you have, epoxy is clearly not a rock. So
right.
yeah.
So I just basically what I do is evaluate the underlying concrete to see if the concrete is the cause of this this blistering. I also evaluate the bond between the concrete and the epoxy. We also have a coating specialist who does organic analysis on the concrete, and her analysis could point us into the direction of what the cause may be as well. We're not quite through this analysis. We actually just started with it, so I'm not quite sure what the cause is.
Stay tuned, everyone, stay tuned.
Yes.
You'll figure it out soon enough. You'll figure it out soon enough what's going on here. Yeah, those sound like really interesting projects, and clearly geologically related. So I am curious about, you've gone through a number of years of scientific training. You've clearly you've continued your education, your scientific training, I should say, at CTL Group. I was curious as to, and I ask a lot of scientists this, how the scientific training, like the thinking, the methodology, all of that, how it, I guess, positively spills over or translate into everyday life for you. Like, for example, like decision-making processes, things of that nature.
Definitely. It's definitely had an impact. I would say that true science really, it teaches us not to see in tunnel vision, if you will. The critical thinking or the analytical mind process that's developed with scientific training, it kind of translates into an awareness of self, of others, and also of information that's being presented to you. I tend to view everything in an analytical way now, and no matter like what or who the source is presenting information to me, I analyze that. I also think that a big part of scientific training is research. So researching each aspect of the topic at hand is important. No topic is just a one-path track. Like I said, with structural geology, it encompasses all these other subsets of geology. And just like at CTL, we can't solve an issue sometimes unless it incorporates all the other science fields in our building. So I think, I think it's definitely benefited me to have scientific training, because I evaluate everything and everyone I come in contact with.
So I think it's great that your scientific training has had positive spillover effects into your everyday life. And one of the things that I talk about a lot with this platform is the benefits of just scientific thinking in general, and learning how to think like a scientist, the critical thinking skills that come along with that. Now, I'm not saying that everyone has to that everyone has to be a scientist and everyone's going to suddenly be an expert in a scientific domain, that they have to do that in order to gain some critical thinking ability. But just having a rudimentary understanding of being a skeptic, that is like looking at a situation and not immediately jumping to conclusions, or if somebody tells you something, not immediately accepting it but not immediately rejecting it either. So kind of finding a good balance there, and how to step by step work through problems, like think your way through solutions, or towards a solution, think your way through a problem towards a solution. I know that for myself personally, that I really benefited in that aspect with the scientific training. And I'm glad to hear that you did as well. I mean, most of the scientists that I ask agree that the scientific training that they received benefited them, obviously not only in their area of expertise, but in kind of all areas of life. That really a lot of these skills can be translated everywhere, particularly when it comes to, you're talking about analytical thinking, et cetera, just working your way through a problem. that this is very easily translated into any aspect of your life. I mean, people, are interacting with each other constantly, not just in work environments. So.
Yes, I 100% agree with that.
It's really interesting to hear your story too. So it's very interesting. And it was fun to talk about geology because I haven't actually had a chance to do that. And it has been so many years since I've actually, done anything geology related, that all of these terms are kind of coming back to me. You're talking about aggregate, you're talking about like, faulting, structural geology terms, the striking dip and things of that nature. And, going back to, you're talking about your journey, about how you ended up in geology, how you found yourself out in the woods because you lived next to a forest preserve and things like that. One of the kind of the feel that I got for the average geology student was that they had just a profound interest in the planet and a respect for it simultaneously. It seemed like a lot of geologists have, which is funny because a lot of geologists, end up working in oil and gas. We know that that's, we learn about global warming and things of that nature. And, so that doesn't really compute. And that's kind of why I shifted away from geophysics, is because that was the route that I was going down. I didn't really want to work in oil and gas. But I just feel as though the atmosphere of the geology department was like, you have this, versus other departments, you have like a profound respect for the planet. You're kind of left in awe of just how cool it is when you learn about it on a more intimate scale, like learning about all the various planetary processes, plate tectonics, learning about the oceans and the various, the way that the ocean columns are stratified, or you learn about glaciology. So yeah. I'm just curious, like, are you like a big, I don't know how to word it. I don't want to say like, are you an environmentalist, but are you like, do you like going out and enjoying, I guess, nature and the planet and things of that nature? And
yes,
something like
definitely, that, yeah. Definitely. I have to hike in the mountains like at least twice a year. It's how I plan my vacations, to be quite honest. It's around some type of nature. So yeah, I would definitely agree that most geologists are really drawn to that nature aspect and respecting the planet. Yeah, and you're right. We do have a lot of people that go into petroleum or mining, which isn't for the planet, but it is definitely a financial provider for people getting into those industries.
Yeah, absolutely. And I don't want to come down hard on our fellow geologists who work in oil and gas or mining or anything of that nature, because, clearly the entire economy that we've built around us over the past 100 years is dependent upon this resource still. So it can't just go away. Also, we still need raw materials to build things. So mining is very important. And there are people working on trying to shift these industries to be more environmentally conscious. So I don't think that they'll ever go away completely, but making them, greening them, so to speak, just making them so they have a smaller environmental footprint, but yet we're still able to keep our society functioning in the same capacity that it is, and then also grow it too, right? Because society, there are more people coming online every day. So we need places to house them. We need, they're going to need automobiles. They're going to need some sort of smart device to communicate. So they need resources. Everybody needs resources. And currently, energy is the most important resource, and the primary source is oil and gas. So, that can't go away overnight. There are plenty of people helping to transition to like renewable energies and cleaner energies and things of that nature. And, when it comes to raw materials, obviously you need mining. Recycling is very important as well, recycling the old used stuff and putting it back into newer things, but you're going to need new raw materials as well. So, and for the individuals who work in those, I don't harbor any ill will. I just know for me that I wanted to shift away because I was going down the geophysics route, and essentially I could end up in academia or I could go and work in oil and gas was basically my options. And I just decided to pivot more to the hardcore physics and move away from geology because that's what I wanted though for myself. And I'm not saying that everybody has to do that.
Yeah, I know a lot of people that, pivoted away from the geology aspect, and even though they got their degree in geology, went the environmental science route for that purpose, that, they were for the planet very strongly. And we need both types of geologists out there right now. So
yeah, absolutely. So one last thing I wanted to ask you. So as somebody, you were talking about how you love to hike and things of that nature. Where are some of the coolest geologically interesting places that you've ever been?
Oh, goodness.
For those who are also inclined to perhaps have similar experiences on their vacations, because it's interesting, if you don't, like here in Illinois, we don't have anything interesting geology unless you like glacial till. Like it's just flat and uninteresting. And it's hard to, I think, develop a real appreciation for nature or be left in awe by its beauty unless you actually go somewhere that's really geologically interesting. So perhaps you could give people some advice here, Jenny, and who are listening.
Yeah.
Where they can go to find geologically interesting vacation spots.
Yeah. So I guess some of my favorites, a couple years ago, I went to Peru, and it's a very short hike, but it's Rainbow Mountain.
Okay.
And it's these, and if people look it up, it's just this beautiful mountain it looks like a rainbow. It's all these different types of colors. The rocks are basically weathered, and they give off, red, blue, green, and it's just breathtaking when you see it. So I would recommend that one. Also, I go to Utah quite often. Utah has a variety of adventures you can go on. It's pretty much for people that are adventurous. I think they have a lot of people that bike. They bike like in the Arches National Park or Zion, or you have part of the Grand Canyon, you have Dead Horse. So there's different types of terrain in Utah. So I think even if you go north, you have more of the mountains up there, or the Rocky Mountains, where the south is the Arches that I'm talking about. And yeah, I've always been fascinated by Utah, so I highly recommend it there. Of course, I lived in Idaho for a bit, and there's something, I love the Rocky Mountains. So I think anywhere in the Rocky Mountains is just a great location to go.
And of course, they have Rocky Mountain National Park in Colorado.
Exactly.
Which is a great place to start, I think, for anybody that's, if you're looking to really experience the Rocky Mountains, that's a gorgeous park. Yes. I've been there.
Yeah.
So have you been there as well?
Yes, I've been there a few times. I have some friends that live out there, and they let me, follow them on trails that, but you don't really want to do by yourself the first time.
Okay.
So.
Well, that's convenient for somebody who likes trail hiking.
Yes.
Okay.
Yeah, I think that's a big plus about being a geologist, is you have all these friends that they kind of go to all these different locations all over the US. Some of them are, global, and so you could just, if you still have those connections, you just call them up and be like, hey, I'm thinking about coming to visit by you. Would you be interested in taking me out on a trail? And most often they say yeah. So.
And the importance of having a network. So, what you were talking about earlier today, talking about networking at field camp and networking in graduate school. It's always important to have people in your network, whether it's just friends or business networks or anything of that nature. But, one thing I was, you mentioned in Peru about the Rainbow Mountain. Is that because of like different mineral compositions or something like that, or do you understand from a geology standpoint as to why that particular mountain is different colors?
Yeah, it is the weathering of those different types of minerals.
Okay.
So yeah.
That's really interesting. I know exactly what you're talking about. I've seen pictures of it, and it looks like something like a 5-year-old would finger paint, with all these different colors and whatnot, because it doesn't even look real. It doesn't even look like, it looks like something you would find like literally on a canvas, not in real life.
Exactly. And it's, the pictures, they're beautiful viewing them, but when you get there, wow, it's just, like I said, it's breathtaking. It's just,
Yeah,
you kind of
pictures.
think you'll never see something like that in your life, and then you're
Yeah.
there.
Yeah, pictures. I've done a number of trips myself, and pictures don't ever seem to do it justice.
Right.
Never. They
Exactly.
did. I mean, our camera technology has improved incredibly over the past, whatever, 100 years, particularly so with the cameras, how nice the cameras are in people's smartphones. But you still just can't seem to capture the beauty
Right.
of this gorgeous 3-dimensional landscape on a 2D, even a panoramic or anything like that. It just doesn't do it justice. And I think it's really interesting that you mentioned Utah as one of your favorite spots. I actually did a trip with some friends because obviously we're in a pandemic, as you know, so we couldn't really go anywhere this past year. I have a group of friends that I love doing a trip with every year. And we really wanted to do like Oktoberfest in Germany because it's something that it's like on all of our bucket lists. We enjoy beer, we enjoy delicious German food. So why not go to Germany and experience Oktoberfest?
Yeah.
As you know, though, pandemic canceled, so we cannot do something like that. So
Yes.
we decided to do a road trip out west, and we did primarily Utah is basically where we focused on. I had never been there before, so we did a bunch of national parks. So I did Zion National Park. We did Capitol Reef, which was incredible. And then there was one more. It wasn't Arches. I can't remember the name of it. Oh, it was Bryce Canyon. That was it. We did Bryce Canyon. So we did those 3, and it was, well, breathtaking. I mean, I just, some of the hikes that we did were incredible.
Yeah.
I took lots of photos. Doesn't
yeah.
do it justice, though.
Yeah, it doesn't. Actually, I heard that the rim to rim trail in Bryce Canyon, I heard that if you hike it through the night and then get to a certain point, that apparently it's like one of the top 10 most beautiful sunrises in the world. So that's on my bucket list.
Okay. I have not heard about that. That sounds intense, though.
Yeah.
Hiking throughout the entire night and then making sure that you're there at sunrise. One thing that we did get to do, which was pretty cool, when we were at Zion, was they had just opened up Angel's Landing, the full hike. So for those who are not familiar, there is like Angel's Landing is like a 3 to 4 hour hike in Zion National Park, and about halfway through, you're in essentially like a chain section where it's like 1 or 2 people at a time because it gets very narrow. You're like super high up. I've never seen cliff faces like that my entire life. I probably only see something bigger than that if I went to Yosemite and saw the huge granite faces there, which is on my bucket list, but I haven't made it yet. But yeah, so we were able to actually hike this because it had just opened up like a day or 2 before, and it was just incredible. It was definitely nerve-wracking, so it's not for the faint of heart. However, it was worth the views. So I don't know if you've ever done that, but I highly recommend it.
I'm actually going to do it in about 4 weeks. So
Okay.
yeah.
All right.
So
That's
any
fantastic.
tips you can give me are welcomed.
Yeah, just don't look down at certain points. Don't look down. Anyway, Jackie, it's been fantastic talking to you. It's been super interesting. Definitely been fun kind of refamiliarizing myself with all of these geologic concepts, these terms, things of that nature. But where can people connect with you if they're interested?
Yeah, so people can contact me via the CTL Group website. It's just ctlgroup.com. You can either go to our people section and find me in a list there, or you can specifically search for my name. You can also look for me on LinkedIn. So yeah, feel free to reach out.
Fantastic. And for those of you that are watching today's episode or listening, thank you so much for stopping by. Definitely go ahead and share, hit that like button, leave us a review. We're always interested in hearing your feedback, and definitely stay tuned. There's more great content coming in the future. Take care.